So this unit is all about exponential and logarithmic functions. And so when you hear the word exponential, what's the first thing you think of? Exponent.
Infinite.
Big. If something is growing exponentially, what does that mean is happening?
It's the universe.
It's the universe.
Multiplying itself by itself however many times the number says to do it.
That was perfect.
Was that actually?
Yeah.
Oh, yeah.
That was really good. I love that. So it's growing at a rapid rate, or it could be decreasing at a rapid rate. And then logarithmic functions are just the inverse of that. So we're going to look at both of them. This specific section is graphing those, graphing an exponential, graphing a log function. And this is the only section where we're graphing. And then the rest of the other sections in this chapter are not graphing, but this is the only one where we are graphing. And all of this will be non-calculator as well. So a couple of facts before we get started, before just things that you need to know before going into this unit. Anytime you have a number raised to the 0 power, so 2 to the 0 power, anyone have an idea of what that would be?
0.
Nope.
2. It would be 2.
1.
1 is always 1. So anytime you raise a number to a 0 power, it could be 1,583 raised to the 0 power. It's always 1. So anytime you have a number raised to the 0 power, it's always equal to 1. So that's the first fact. The second fact would be anytime you have a number raised to a negative power, it is like saying, so a negative exponent means that you change it to be the reciprocal. So the reciprocal of 2 over 1 is 1 over 2. So 1/2. So anytime you have a negative exponent, it's like putting 1 over that number, putting it on the denominator. So if you had 2 to the negative 2, it's like saying 1 over 2 squared.
Could you just put 4?
1/4. So a negative exponent, like to make it a positive exponent, you have to put it on the denominator. So it's negative on top, like this, but then it's positive on the bottom. So it's like once it crosses that line, it becomes positive. So what I want us to do for number 1 is I want us to fill out the table. We can start with 0. So 2 to the 0, we already said, is 1. 2 to the first power. 2 to the second.
4, 8.
And 2 to the negative 1, we said, is 1/2. 2 to the negative 2.
1/4.
2 to the negative 3. 1/8. Good. And so from that, yep.
So could you just take like the numbers that you do, like the 1, 2, and 3, and just put them on the denominator?
Yep, exactly.
How do we get these numbers?
By plugging into this function. So I'm going to plot my points. And as my x value is getting smaller, so like the negative numbers, what's happening to my y value? It's getting closer and closer to something. 0. The x-axis, or 0. So we call that, if it's getting closer and closer and closer, we call that an asymptote. And I think we've used that word before. But an asymptote is like a magnetic field where your function is approaching it, but it never touches it. So picture like, I drew this for the last class, picture like a wizard. Here's my picture of a wizard. And this is my wizard, and he's saying, you shall not pass. So nothing can pass what we call the asymptote, which is y equals 0. So my numbers are getting closer and closer and closer to 0, but they never touch it. Okay, we're going to do our domain and range in interval notation. So domain for this function will always be negative infinity to positive infinity. It never stops. And then my range, I read it from bottom to top. In this case, my range is going to start at my asymptote, which is what?
0.
It starts at 0 and then it goes to positive infinity. But I'm gonna put a parenthesis by 0 because it doesn't actually touch it, so there's no bracket.
Is it ever going to go to negative infinity?
If the whole function were flipped, which if you have a negative function, it'll flip. So we'll see an example where it does that. Okay, so then it has end behavior. The end behavior, or actually it says increasing or decreasing below that. How you tell is what it's doing to the right. So as my x values are getting bigger, is my function getting bigger or getting smaller? Bigger. So I'm going to say it's increasing. So circle increasing. And then lastly, it has end behavior. Something that you'll notice on the notes for this is, what do you notice about how this is different than the way we've been writing it on your notes?
It's not just up or down, it's to the left.
Is infinity first?
Yeah, it gives you infinity first and then negative infinity. And I normally switch it, so that kind of bothers me a little bit, the OCD-ness inside of me. But I couldn't edit it, it wouldn't let me, so. As x is approaching positive infinity, f of x is doing what? So this is to the right. What is my y doing to the right?
It's increasing.
So I'm going to say positive infinity. And then as x is going to negative infinity, so to the left, what is my y value doing?
Staying the same.
But it's going to what? It's going to 0. So you're just going to look at your range. All you're going to do is look at your range. Negative infinity is this number. Positive infinity is this number. So just look at your range.
So 0.
Yes. Okay, so the next thing, I want you to try filling out, number 2, I want you to try filling out the chart. And remember, talking about a negative exponent, it flips the reciprocal, so it becomes the reciprocal. So if I had 1/2 to the negative 1, what do you think would happen?
2.
Flip to be 2. Good.
Oh, so it's just the opposite.
Yes.
We should have little like meme buttons on our desk for like whenever you say something.
That'd be cool.
Got Graham.
So try doing number 2 on your own. So I filled in the table. It's just the opposite of 2 to the x. The asymptote would be y equals 0. Domain always negative infinity, positive infinity. Range, if I'm reading it from bottom to top, is 0 to positive infinity. It is decreasing because to the right it's getting smaller and smaller and smaller and getting closer to 0. Then here I have the end behaviors. I shouldn't want to scroll down so that you could see the whole thing. But as x is approaching positive infinity, so to the right, my y is going to 0. And then to the left, my y is going to positive infinity.
So sometimes you can't just look at the range.
You can always look at the range, but deciding which one to use determines whether it's right or left. Okay? So this is the parent function of what you're going to see. All exponential functions will go through 0a and 1ab, which I'll discuss here in a minute. Because whenever you're graphing it, I'm going to have you plot 2 points. You'll also see on some of these exponential functions where the base will be the number e. Since this is all non-calculator, we are going to estimate e to be about 2.7.
It's all non-calculated.
Mm-hmm.
Wait, is that A or 9?
A. Yeah. So it's kind of like saying, this hurts my heart just a little bit. It's like saying pi equals 3.14. We're going to say E is 2.7. And so E is a constant. It's irrational, meaning that the decimal repeats it doesn't repeat, but it goes on forever. And we're going to just round it to be 2.7 for this so that we can still graph it on a non-calculator part of the test. You use E a lot in, like, you know how I'm assuming that, like, when you maybe invest in something and it accrues interest and it can be compounded. Have y'all heard about, like, compound interest and stuff like that? So business models and determining compound interest and things like that use the number E in order to solve for how much interest is accruing and things like that. So E is just a number, it's a constant, and it's about 2.7. Below, we're also going to talk about how the parent function is transformed. So how exponential is transformed. You all should know most of these because we've been doing them since the first unit, but we're just going to kind of refresh our memory. So the number in front, A, is a vertical stretch or shrink or compression, whatever you want to say. How do I know whether it stretches and whether it shrinks?
It's a positive or negative. That's more.
Not positive or negative, but number greater than 1. So if
Oh, yeah.
A is greater than 1, then it stretches. If the absolute value of it is less than 1, then it shrinks. So if it's like a fraction less than 1. I don't have this written, so we're going to add it, but B, which is the number in parentheses, is a horizontal stretch or shrink. H tells me what it does, how it shifts what? H. Left or right. And remember, you take the opposite sign. And then K tells me up or down. Also, Y equals K is going to be my asymptote. So in the first two examples, there was no K, like there were no values outside of it, but it'll always be your asymptote. Now, if you have a number that is in front of the A, so if you have like a negative A value, then it's going to reflect the x-axis. If you have a negative x value, it's going to reflect the y-axis. And it'll just take some practice, but you'll start being able to recognize and get the hang of it. There's only a few new ones that we haven't seen before. So let's look at number, wait, this isn't right. Okay, so let's look at number 3. Now, when you are graphing, there are 2 points that I'm going to be grading or that I'm checking. And so when you're graphing, you want your exponent to equal 2 things. You want your exponent to equal 0 and you want your exponent to equal 1. I'm going to write this at the top. So exponent equals 0 and 1. And I'm going to put in parentheses or negative 1 if a fraction, which I'll show you here in a minute. So I'm going to set this up. You can either do this in your head or I'm just going to write out all the steps, but it'll become where you start doing it in your head. So x minus 2 equals 0, x minus 2 equals 1. So my 2 x values that I want to plug in are 2 and 3. Good. So when I plug in 2, I get negative 5 to the 0 power. Anything to the 0 power is what? 1. So my answer, my y value would just be -1 because there's a negative out in front.
How did you get the -1?
Because you have -5 to the 0 power. This becomes 1.
Oh,
and
yeah,
then
okay, I
negative.
get that.
When I plug in x equals 3, I have -5 to the first power. So I end up getting just what? -5.
Where did you get x minus 2 equals 0 and x minus 2
Yes.
Those are the two numbers that I'm plugging in to plot my points.
You can use any?
No, you have to use 0 and 1.
You used to.
Oh, you used the
X minus 2 equals 0 and x minus 2 equals 1. So I'm setting my exponent equal to 0 and 1.
So anytime you have an equation in the exponent, you set it to 0 and 1.
Uh-huh.
Or, and then it says, if it's a
-1.
-1
Yeah,
instead
we'll
of
do.
1?
Uh-huh.
Okay, but you still do it to 0.
Yes. So I'm going to plot those 2 points. Do I have an asymptote? Like, do I have a K out to the side? No. So I'm just going to put it at 0. And then I'm going to connect my dots. So you use the dot that is closest to your asymptote and draw that along the line. And then the other one goes in the opposite direction. Domain is always -infinity, +infinity. Range, reading it from bottom to top, -infinity to 0.
So that 0 is always the A.
The K.
The K, yeah. Like
It's not always the K, but my end behavior, so to the right, as x is approaching +infinity, what is my y doing? -infinity. To the left, 0. Okay, let's look at number 4.
Is the domain always going to be bottom?
Yes. For exponential. When we get to logarithmic, it'll switch, but for now, yes. Oh, so to the right, what is it doing? Decreasing. Good.
So you always ask for that. What is it doing towards
To the right. Okay, number 4, I want to set my exponent equal to what 2 numbers? So I need to set x equal to what for 0? If I divide each side by -1, I still get 0. 2 to the 0 power is what? 1. 1 minus 3, -2. Good.
I'm confused on how you get the Y.
I plug it in.
Like the-
So 2 to the 0 minus 3 equals 1 minus 3, which gives me -2. So that's how I got this. So once you get like what x value you should use, you plug it in and solve for the y.
Oh, yeah, that makes sense.
The next one, so what x value do I want to use to get, I divide each side by -1, so x equals -1. And when I plug in -1, I have 2 to the -1, so 2 to the first power, minus 3. 2 minus 3 gives me -1. So my y value is -1. I'm going to plot both of those points. Now, my asymptote is my k value, which is what?
3.
-3. You keep this sign for asymptote. Then you connect your dots and you take the point closest to your asymptote.
How do you know the asymptote's -3?
Because the k value right here. So the number on the outside. Domain is always range. Starts at -3, goes to positive infinity. Yeah, always parenthesis. Increasing or decreasing? Decreasing. Because to the right it's getting smaller.
So that's the
To the right, it's seeing the
y
same.
value?
It's getting smaller and smaller and smaller, and it's getting closer to -3. It's not actually touching it, but this is not a straight line. It's like getting progressively smaller and smaller and smaller, just in tinier increments.
Will it ever
That makes
hit?
no sense whatsoever.
Will it ever hit?
This is going down. It's not going
The
straight.
yellow line or the orange line?
The orange line. It's just at a very tiny rate.
How do you know it's not going up? Like, why are you saying it goes down?
Because 2 to the negative, so if I do 2 to the -2, I get what?
4.
1 over 4. If I do 2 to the -5. So I'm going from here to here.
1 over 25.
1 over, what's 2 to the 5th power? 32. Good. So what is the difference between these two numbers right here? Which one is smaller?
1 over 32.
1 over 32. If I kept going out, like 2 to the
Well, how do you
-25th power, it would be 1 over whatever 2 to the 25th is, which is a huge number, which is really, really tiny. So
do you math to find it, or you need to look at it?
just look at it.
Will it ever hit -3?
No. It's going to get so close, but it's never going to hit it.
This, but if it was like this, would it be increasing?
Mm-hmm. Yeah. So as x is approaching positive infinity, so to the right, it's approaching -3. So number 3 is not increasing because it's going down. You just look at where the arrow is going. Is it going down or is it going up? This is going down at a more rapid rate, but it's still going down. Yeah, you look at what it's doing to the right.
Okay.
And then as x is going to the left, it's going to positive infinity.
Okay, that makes sense.
Okay, the last thing I want to do is write in the transformations. 'Cause on the homework it asks you for transformations. So let's look at number 3, transformations. Somebody give me one transformation on number 3. Reflects x-axis. Good. Because of the negative. What does the 5 tell me? Look at your notes. It's the B. Horizontal stretch by 5. And what does the x minus 2 tell me? Left to right. I take the opposite sign, so right 2. And you can also look at the picture, and it looks like it's going to the right. Okay, number 4, transformations. What does the 2 tell me? Horizontal stretch. What does the negative x tell me in the exponent? Reflects y-axis.
And then it goes down.
Because if you have a negative exponent, it reflects the y-axis. But it doesn't shift left or right any, because there's no number with next to it. And what does the minus 3 mean? Down 3. Good. Number 5. So what do you notice about the number that's attached to the exponent already? It's not a
whole number.
Yeah, so it's going to be a compression because it's a fraction. So anytime that you have a fraction, we are now going to set the exponent equal to negative. So x plus 4 equals 0. Keep the 0. And then x plus 4 equals negative 1. And why? Someone take a wild guess why you think we'd want to do that instead of leaving it at 1.
Because it's a fraction, it would probably help us solve it.
So if it's a fraction, what happens when I raise 1/3 to the negative 1 power? It goes to 3. It goes to 3, which is going to help us out. That means we don't have to multiply by fractions. So, yeah, so change it to be negative 1 and it flips it back. And so, that is why I do it. So the two x values that I want to use are, the top one will be what? Positive or negative 4.
How did you get negative? Oh, wait. Because
I move it over.
that's on me.
Okay, so when I plug in negative 4, I get 2 times 1/3 to the 0 power. And anything to the 0 power is what? So 2 times 1 plus 2 gives me 4. So 4, negative 4, 4.
Is the other one negative 5?
I plugged in negative 4 for x.
So they cancel out.
Yes.
Then you do 2 times
1/3 to the 2 times 1, because anything to the 0 power.
2. Oh, plus 2. Okay.
Yeah. Right here. Here's my work. Do you see it?
Yeah, I got
Okay. Okay.
And I said to the 0.
And that's when you
Because
plug in
negative 4
zero,
plus 4.
right?
Okay. The next one I want to plug in is when x equals what?
Negative 1.
And so I move this 4 over, and I get x equals negative 5. So when I plug in negative 5, I get 2 times 1/3 to the negative 1 plus 2. Because I'm plugging in negative 5.
What's 8? 8.
And 2 times 3 plus 2. 6 plus 2 gives me 8.
Oh.
Yeah.
So my 2 points I'm plugging in are negative 4, 4, and negative 5, 8. Erase this now. What is my vertical asymptote? 2. I'm going to connect the dots and draw the one that is closest to my asymptote next to it. Domain is always. Range starts at 2 and goes to positive infinity. My asymptote is y equals 2. As it's going to the right, is it increasing or decreasing? Decreasing. Decreasing to the right. As x is going to positive infinity, so to the right, it's approaching 2. To the left, positive infinity. Okay, I want you to try number 6. Oh, wait, we got to write our transformations first. Sorry. Let's name some transformations. Vertical stretch by 2. What's another one?
Horizontal compression.
Good. Horizontal shrink or compression by 1/3.
Oh, the fraction.
Isn't it like
Left or right?
left?
Left 4,
And then up 2.
up 2. Great.
I'm getting it.
Okay, with number 6, it's 4 minus x. You can rewrite this as 4 to the negative x plus 4. That might help. But either way that you do it, to start out, I'm going to get my 2 points. So I want to set this equal to what two numbers? 0 and 1. Good. So try number 6. I want you to do the whole thing, including the transformations. So the 2 points that you choose are 4 and 3. And then when you plug those in, you get a y of 1 and 4. Okay, let's go to the next page. Okay, remember that E is about 2.7. That's what we're going to use for non-calculator purposes. And so same rules still apply. E is a number that's bigger than 1, so I'm going to set it equal to 0 and 1 again. I'm not going to do negative 1. So I want to set my exponent, which is just x, equal to 0 and 1. So that makes life really easy. So when I plug in 0, e to the 0 is what? 1. So negative 1 plus 5 gives me what? 4. Did everyone see how I got that? I did negative e to the 0 plus 5.
Easy work.
Negative 1 plus 5, 4.
So E is just a negative.
So the x is whatever the exponent is,
Uh-huh.
and then the y is whatever it
You get when you plug in x, yes. Okay, when I plug in 1, I get negative e to the first power plus 5. So negative 2.7 plus 5 gives me what? Negative 2.7. So 2.3. So I'm going to plug in those two ordered pairs. 0, 4, 1, and 2.3. My asymptote will be where? 5. So now it's going to be below the asymptote. So I'm going to connect the dots.
Wait, down.
I don't see where you got
2.7 is E.
I didn't know
Because it's a constant. It's like saying pi is 3.14. Domain, negative infinity, positive infinity. Range, negative infinity 5. Great. Is it decreasing or increasing? To the right, it's going down. As x is going to the right, y is to the left. Good.
Easy.
Transformations.
I hate
Horizontal stretch by E. Don't put 2.7. I like E better. Reflects x-axis. And last one is up 5. Okay, try number 8. Okay, so for number 8, the 2 points that I want to set 4 minus x equal to 0 and equal to 1. So the two x values I chose for it to be equal to 0, I chose x equals 4. When I chose it equal to 1, I chose x equals 3. When I plug them in, you get 1 plus 1 is 2. 2.7 plus 1 is 3.7. So plot those points. Vertical or horizontal asymptote at 1. And transformations.
Oh my gosh, these transformations are killing me.
Now we're going to do the opposite. It gives us the graph and we're going to find the value. So y equal, I'm just going to write the parent function. B to the x minus h plus k. We're not going to worry about any a values for this. Just one. And I'm going to put b in parentheses. So, no. So, something that we can use right off the bat is the k.
Plus 2.
And so on number 9, my asymptote is at 2, so I know that it's going to be plus 2 at the end. The next thing that you do is you look at the point that is closest to your asymptote, which is this one right here. That tells you your left or right shift. And so I'm going to start at 0, and I'm going to count 1, 2, 3, 4, 5, 6. So that means that it's going to go left 6. And so my exponent will it be x plus 6 or minus 6? Plus 6. Now I need the number in parentheses. So you take the point that is the next point, 1x value away from that. And you count the vertical distance from your asymptote. So it goes up from your asymptote. So 1, 2, 3, 4, 5.
What?
So a 5 goes here. You use the actual number. If it's increasing, you use the number. If it were decreasing, so like in number 10, it's going to be 1 over that number, like a compression. So let's look at number 10. I'm going to put a dot right here and ignore this one. There's a little typo. Not a typo, but just put a dot here. So where's my asymptote for number 10? Negative 5. So y equals, and then I'm going to have negative 5 at the end. I'm going to use the point closest to my asymptote. That's going to be my left or right shift. So it does what? It goes right 4. So x minus 4 as my exponent. Then I'm going to take the distance from my asymptote to my next point, which is 3, but it's decreasing, so it's 1 over 3.
Oh, so it's going backwards?